Chapter 6 Energy, Temperature, and Heat. Section 6.1 Radiation Transfer and Temperature. Okay, let's review what we've learned so far about radiation and how radiation produces heat energy and that affects the temperature of an object. So we know that heat can be produced by the absorption of radiation. If we increase the amount of radiation, the temperature of that object will grow hotter. If we reduce the amount of radiation being received by that object and converted it into heat, of course, the object would grow cooler. If input and outputs remain the same over time, then that object would maintain a constant temperature over that period. The Earth, for example, it has more or less had a constant temperature over the last, let's say, 1,000 years, minus what's occurred during the Industrial Revolution. And basically what we had was the input that was coming from the sun remained constant, therefore the output or the heat energy generated was a certain quantity, and that quantity stayed the same, and the amount of long wave leaving remained the same, was constant. In the last 300 years, the enhancement of the greenhouse effect by adding greenhouse gases has influenced the long wave process, that less long wave is leaving relative to short wave coming in, and this is causing the Earth to warm up over the last 300 years. These three diagrams model what I've just described, this idea that the absorption and emission of radiation from an object, the quantities, determines whether or not an object heats up or whether or not an object cools down. So for example, in A, the amount coming in is much greater than the output, so the object would heat up until it reaches an equilibrium condition where input equals output. If in B, if we suddenly reduce input of radiation, the object would start cooling down because the amount of long wave that's leaving is much greater than the incoming short wave. It would cool until once again a balance exists. And C describes a balanced condition. So in a balanced condition, temperature remains constant over time because input equals output.